Excellent. Okay, so when we do the Pythagorean theorem, you're only going to use right triangles. Well, kind of. It only works on right triangles. The Pythagorean only works on right triangles. How do we know it's a right triangle? I know, it's a hard one. How do we know it's a right triangle, John? If it's marked, or if there is an angle that is 90 degrees, we have a right triangle. Could there be two 90-degree angles in a right triangle? Can there be two 90-degree angles? No, because two 90s makes 180, and how many angles do we need to make 180? 3 of them. Got it. All right. Then in this right triangle, we have across from or opposite the 90 degrees is always the longest side. Opposite the 90 degrees is always the longest side. You know why the longest side is across from the 90 degrees? What's the biggest angle in a right triangle? 90 degrees. So the longest side is always across from the largest angle. We call this longest side the hypotenuse. Did you just read that, or did you remember it? All right. So the hypotenuse. Now the other two sides, sometimes they are the same length, sometimes they're not. It does not matter which side is A and which side is B. They are both called legs. Leg. And then the Pythagorean theorem, this always is true, that a squared plus b squared equals c squared. This will always be true if it's a right triangle. Now, a lot of times, the numbers that get squared and equal the other number squared are nice integers. Here's a huge selection of these nice integers that make a squared plus b squared equals c squared. My favorite one is 3 squared plus 4 squared equals 5 squared. Let's just check that over here. 3 squared plus 4 squared equals 5 squared. What would I do first, order of operations? What would I do first to check that? What? The exponents, right. So I'm going to do 3 squared, which is 9, plus 4 squared is 16, equals 5 squared is 25. And then I'll add 9 and 16, and I get 25 equals 25. So that does work. Anytime we have integers that fit into the Pythagorean theorem, we call them triples. And here's a big secret. On the ACT, a lot of times on geometry questions that are all over the ACT, they will use triples because if you have them memorized, you don't have to do this work. If I know that there's a right triangle that has one side, one leg of 3 and one leg of 4, I don't have to do the Pythagorean theorem because I already know 3, 4, 5. Like I have that one memorized. So these triples, people memorize to save time. And what's also great about these triples is talking about similar triangles that we just spent a while on. If I have a 3, 4, 5 triangle and I take a scale factor and I triple all 3 sides, if I triple all 3 sides, I will now have a 9, 12, 15 triangle. And look, that is also a triple. So the scale factor to the 3, 4, 5, any scale factor would work. So if you know 3, 4, 5, you actually know a lot of triples. 5, 12, 13 is another triple. 8, 15, 17 is another triple. 7, 24, 25 is another triple. There are more. These are just the 4 that I have memorized, and the 4 that most people have memorized, and the 4 that your book will use all the time. So you want to save yourself time. You don't want to have to do the Pythagorean theorem every single time if you see some of these numbers show up. So example 1, using the Pythagorean theorem. Find the value of x, then tell whether the side lengths form a Pythagorean triple. So over here, out of these 3 sides, we're going to determine which side is the C. C is the longest side. C is the hypotenuse. I didn't say that up there. I kind of said it, but C is hypotenuse. The A and B are the legs. So out of these 3 sides, which one is hypotenuse? X. This is the C. So we'll set this up as 5 squared plus 12 squared equals x squared. And then we're going to add the 5 squared and 12 squared. So 25 plus 144. Somebody want to grab that? Please, thank you. Jay. We have a story for you later. So I'm going to add together 25 and 144. Thank you. We get 169 equals x squared. What happens next? We need to square root. But let me remind you of a rule that's really important that goes all throughout every math class you ever take. That's right, Abney. If you square root an x squared and the other side of the equation, you have to put a plus minus in, because you don't know what x originally is. X could have been a negative number that got squared and became a positive 169. So now I'm going to have x equals, does anybody know the square root of 169? It is 13, so I have plus minus 13. Now I'm going to take this and I'm going to look at my actual triangle. I have a positive 13 and I have a negative 13. Can I have a negative 13? No. That's how I solve the equation, but I can't have a negative 13 for my answer, so I'm going to reject negative 13. We're only going to have that x equals positive 13. Why did I spend time putting in plus and minus if I knew I wasn't going to use it? Do you know why I spent that time? No. Because sometimes you need plus and minus, especially next year a lot. I just want to make sure that you practice it this year so it's not like brand new next year when everything else is hard. Junior year's the hardest. Okay. Now, the second part, tell whether the sides form a Pythagorean triple. Do we have a 5, 12, 13 triple? Yes. So I could have, if the directions didn't say use the Pythagorean theorem, I could have said 5, 12, oh, that's a triple, 13, done. See? Triples are fun. They make it go faster. All right, next one, find the value of x. Tell whether the side lengths form a Pythagorean triple. Out of these 3 sides, which side is C? That's what you want to start with. 14 is the C. That's the hypotenuse. So then we'll do 7 squared plus x squared equals 14 squared. Now we're going to square, so we got 49 plus x squared equals 196. Subtract your 49. It's 147. What am I going to do next? Okay, but if I'm putting in a square root, plus minus. Okay, I'm going to go ahead and reject the negative square root of 147 because I know that can't be an answer, but I knew how to solve it. So we're going to look at positive 147, square root 147. No, no. Square. No. But can we simplify 147? Is there a perfect square that divides out of square root of 147? Not sure? Do you know? 7 and 21 makes 147, but I want either the number 7 or the number 21 to be a perfect square, which they are not. But if you think about the numbers, there is a perfect square in there. 49 times 3 is 147. 49 is a perfect square, so we need to simplify that perfect square. 7 and then square root of 3 doesn't simplify. So that's our x value. We've done this a few times this year. This chapter we're going to practice simplifying radicals even more. So if you still need help with this, you come see me and ask me questions. Okay? All right, here's a real life application. So skyscrapers are connected using a skywalk. So there's the skywalk. And they're held together with support beams. We got our support beams. We're going to use the Pythagorean theorem to approximate the length of each support beam. Are they going to be different? No, so we just need to find one of them, right? All right, so out of these three sides, 23.26, x, and 47.57, which of those three sides is C? X is C. How do we know? It's opposite the 90 degrees. It's not touching the 90 degrees. It's opposite it. So x is the C. That's the hypotenuse. So we're going to do 47.57 squared plus 23.26 squared equals x squared. This is where you might want a calculator. You have a question.
If we're solving for one of the triangles, shouldn't we split 23.26 in half because it's the whole?
I don't think it is the whole. I think it's saying that each part is 23.6.
Oh, okay. I didn't know.
Yeah. I mean, I looked at it too, and that I guess it's kind of hard to tell. But I think, in my opinion, I think it's each part is 23.6. But yeah, if it was the whole, then we would split it in half. Okay, again, you probably want a calculator for this. And by the way, I'm just going to do one line. I'm going to type it in like this. 47.57 squared plus 23.26 squared equals that number. $2803.9325 equals x squared. Is that my answer? This is not my answer? Jesse, what's wrong?
So with that, you have to square root both of those.
Oh, yeah. I need to square root still. And what do I do if I square root? Plus minus. But what am I going to do with the minus? Reject the negative. Now, since this is such an awful number, it's already decimals, just going to go ahead and find the decimal answer. We're not going to try to simplify this one. All right, on my calculator, I can do square root, and then I can put this answer in. There's a few different ways of doing it, but I can do second negative. Yeah. So my answer is approximately, it's not going to be equal, like, you know, it does say find the approximate. So my answer is approximately 52.95 meters. All right, here's some just review. Number 1, is it a triple? If you're not sure, you can go scroll back. Is there a triple that has 2 legs, a 4 and a 6? Or maybe they reduce. Maybe the 2 legs are a 2 and a 3. Any triples that have 4 and 6 or 2 and 3? Nope. This is not a triple. Then we need to do Pythagorean theorem. Of the 3 sides, which is C? Did you say 6? Oh, definitely thought I heard 6. Okay. So that is the hypotenuse, x. Cross from that 90 degrees. So we do 4 squared plus 6 squared equals x squared. 16 plus 36 equals x squared. What is that? 52? We square root and we put in a plus minus. Square root, we're going to reject the negative. And I've got x is square root 52. Am I done? Oh, Alex says no. Does anybody else have an opinion? You don't have an opinion, or you're saying no also? Why did you say no, Alex? Am I done?
Oh, because you have to simplify the rest.
Does this one simplify?
I have not.
Oh, okay. So you're just guessing that I might. So yeah, we need to check to see if it can simplify. We need to see if there is a perfect square that divides evenly into 52. Anybody know anything about cards? How many cards in a deck? 52. How many suits?
4. Oh, so 4 and 13.
4 and 13, yeah. That's what I think of anytime I see 52 is cards. Not everybody plays cards, but. So 4, the square root of 4 is 2. Then square root of 13, we don't know, so we bring it down. And that would be our answer. So these are not a triple. Not triple. How about number 2? Is it a triple? Just double check which triple you think it is. 3, 4, 5. In order to be 3, 4, 5, the 3 has to be a leg, and the 5 has to be the hypotenuse. Is it? Okay, so then yes, this is the triple. And then we can write x is 4. Done. And you know what? If you don't realize it's a triple till later, you do the Pythagorean, you get the right answer anyway. Hopefully. Let's just say hopefully. All right, I'm going to skip that next problem. We have one more portion of this. It's called the converse, which is if I give you all 3 sides, and if you do a squared plus b squared equals c squared, and it works, that tells you this is a right triangle. So if we do all 3, a squared plus b squared equals c squared, and it works, then you have a right triangle. So in question A, I'll know if it's a right triangle. We're going to see. If this is a right triangle, what would C be? Is square root of 113 bigger than 8 and 7? Without on your calculator checking, do you know? Think of a square root you know the answer to that's near 113. Square root of what? And that's what? 10. It's already bigger than those, so yeah, this has got to be the biggest side. Or you can check on your calculator. I just wanted you to think. All right, so that's the biggest side. That means that one's the hypotenuse. If it is a right triangle. Squared plus 7 squared equals the square root of 113 squared. Do you have a question? Have any? Okay. Did you have a question? I will in a moment. Yeah. So 8 squared is 64. 7 squared is 49. Anytime you square root and square a number, these are inverse operations that undo each other. So we get 113. And 64 plus 49 is it? I didn't check it yet. Yep, 113. So then, yes, this is a right triangle. Because the Pythagorean theorem worked. All right, these three sides over here, which one would be the hypotenuse if it is a right triangle? I'm looking for square root 95 is close to, this is close to square root of 10, and 4 times that would be like 40, so yeah, I think that's the longest side, or you can check on your calculator. So we'll make that one the C. 36 squared plus 15 squared equals 4 square root of 95 squared. Don't rush ahead of me on this one, because this one, there's something on here that people make mistakes on. 36 squared is 1296. 15 is 225. Okay, over here. 4 square root 95 squared. This is the same thing as 4 square root 95 times 4 square root 95. And if we're multiplying things, oh, do you know what 4 square root 95, what operation is in between them? That's multiplication. So right here, this is the same thing as 4 times square root 95 times 4 times square root 95. And with multiplication, you're allowed to multiply in any order that you want. So I'm going to multiply in the order of 4 times 4 times square root of 95 times square root of 95. What's 4 times 4? Okay. And then the square root of 95 times the square root of 95 is the square root of 95 squared, which is, did I go too fast? The square root of 95 times the square root of 95 is just saying the square root of 95 times itself squared. So that's just 95. Now, you do not have to do this work every single time. I did this work so you could see why the 4 became a 16. I think you can see why the square root of 95 changed into 95. People forget the 4. They forget that 4 and they don't make it a 16. They like leave it a 4 and then they get the answer wrong. So I just want to make sure we know that there's 2 4s multiplying here. Okay, 16 times 95, I don't know. 1520. And then 1296 plus 225 is 1521. What does that tell me? Not a right triangle. That's how the converse works. It tells you if it's a right triangle. One more thing. Last thing. See, we're almost already done. Pythagorean theorem. Easy stuff. Pythagorean theorem, inequalities theorem, says if we do a squared plus b squared equals c squared and it's not equal, one moment, Okay, if we do the Pythagorean theorem and it does not work, you can actually say if it's an acute triangle or an obtuse triangle with what you get. If you do a squared plus b squared, and it is, if the c squared is smaller, it means it's acute. So we can remember that if the c squared is smaller, it's acute. If we do a squared plus b squared, and the c squared is bigger, then it's obtuse. That last question that we just answered, this was not a right triangle. Was my c squared smaller or bigger? So what kind of triangle is this actually up here? What? Oh, it's acute. So acute. Okay, so we got 3 examples. Verify the lengths 4.3, 5.2, and 6.1 form a triangle. And then is the triangle acute, right, or obtuse? Do you guys remember there was this one activity that we did where we had like markers, and we had decided that we had to have a certain amount of markers to actually make a triangle in the first place? Yeah, so we need to verify that this is a triangle, and then is it acute, right, or obtuse? To verify that it was a triangle, if you add up 2 sides, always is bigger than the third side. That would be true, right? If I add up 2 sides, 5.2 plus 6.1, that would be bigger than 4.3, right? If I add up 4.3 plus 6.1, that's bigger than 5.2. Okay, so it is a triangle. Now, is it acute, right, or obtuse? So which of these would be the C? Okay, that's going to be my C. A and B don't really matter. 4.3 squared plus 5.2 squared equals 6.1 squared. Use your calculator. Might even take a shortcut on my calculator. Look at this. 4.3 squared plus 5.2 squared equals, and then 6.1 squared. Well, it's not equal. So it's not a right triangle. What do we know about C? C is smaller. This one's acute. C is smaller. Acute. Hmm, 3, 4, 6. Do they form a triangle at all? Do they form a triangle at all? We need to add these up. Do they always equal the, are they always greater than the other side? Do they form a right triangle, or not a right triangle, any triangle? So yes, triangle. So we may proceed. 3 squared plus 4 squared. I know it's not going to be a right triangle. You know why? Because it would be 3, 4, 5. But it's not. So the C is bigger. So what's that tell us? Obtuse. You guys are so into this, I can totally tell you're having fun. Last one. Do they form a triangle? Aaron, did they form a triangle? Yeah. Steven, what am I going to do next? Did I wake you up, dear? That's why I called on you. Steven, do you know the Pythagorean theorem? Okay, so tell me what am I going to do with these three? You gotta be a little bit louder, huh? 2.1 squared. You got a calculator handy? You have a computer handy? Cameron, you got a calculator handy? Is that a yes or no? Computer? Cameron, I would like you to tell me 2.1 squared plus 2.8 squared. Oh, add them together for me. I don't care individually. Just tell me the total add of them. It's not what I got. I have to try again. You got it. You're good. And while Cameron's working on fixing that, Stephen, can you tell me this side? So mean, I call them the people with no calculators. Okay. Jay, what's this tell me? Right triangle, perfect. Yay. Done with notes. So after your test on Friday, we're going to have some Pythagorean theorem assignment. Okay? I can possibly give it to you early if you're like, okay, I've studied for the test, I have nothing else to do, what can I do before Friday? I can give you the test as Pythagorean theorem stuff.